Greetings, my name is Francesco Ceccato. I am a student at I.T.T. Barsanti. If you're listening to this, then this is likely your last year in I.T.T. Barsanti. Therefore, there is something I want to show you at all cost, namely the HTML5 Advanced Theory course with notions provided by the W3C, the World Wide Web Consortium. Well, let's begin with a historical remark. Unlike what many people believe, the web is far from being the same thing as the internet. The web is the result of the meeting between hypertext and the internet. Hypertext is a technology invented in as early as the 1960s by two distinct American computer scientists, Ted Nelson and Douglas Engelbart. On the other hand, the internet was invented by the American government nearly a decade later, in the 1970s, as a computer network with military and educational purposes. Back then it was known as the ARPANET, and as time passed it evolved and became what today is known as the Internet, a global network. It is the British scientist Tim Berners-Lee who is credited with this meeting. In the 1990s, he had the ingenious intuition to link hypertext to the internet, and in doing so he invented the World Wide Web. But wait, what is a hypertext? Basically, it is some sort of document which allows you to jump, to leap to a totally different one simply by interacting with one or more keywords. Before the invention of the web, browsing the internet was much more complicated, as the only available tool was Gopher, a hierarchical navigation system. Alright, let's assume you wanted to reach a certain document starting from a different one using Gopher. Well, then you would have to go to the superior level, which means the folder in which the original document was located. Then reach the root folder, move to a different folder, the one which contained your destination document, and then you ultimately open it. In the same way you would browse through your images, your Excel, Word documents stored inside your hard disk. And believe me, it was quite painful. Nowadays it's much easier to browse the web. Well, the web is made of some core components, for example the Hypertext Transfer Protocol HTTP, the Hypertext Markup Language HTML, which is the language web pages are made of, and the URL, the Uniform Resource Locator, which is a string of text that identifies a unique document in the web. Tim Berners-Lee is credited with developing the concept of browser as we know it. The first browser was named World Wide Web. It was introduced in 1991. Here we can take a look at a screenshot of NCSA Mosaic, a quite old dated browser, maybe a bit newer than World Wide Web, but not much different. You can see there are no tabs. You could visit only one website at once. Yeah, got me. Very well. In this course I will cover some aspects of a couple of languages belonging to the HTML5 suite. The HTML5 language, the core of the web pages, all the content of the page organized into a logical structure, the actual pieces of text, images, what you want to show the user, what is the backbone of your page. Then we have CSS3, which is all about the style of the page, the presentational features of the page which are not necessarily related to the content, such as colors, borders, margins, sizes, and so on, which also means that HTML5 is supposed to be coherent, is supposed to be adequate to work even without CSS lines of code. Then we have JavaScript, JS5, which is about user interaction, that allows you to customize your page according to any number of parameters to create animations. However, this is beyond the scope of this course. You can check it out for yourself if you want to. Very well, we know that the letter M in HTML means markup, but what is the meaning of markup? Essentially, a markup language is used to annotate documents with extra meta information that tells about an underlying logic or structure that must be respected. Mind that this meta information is not supposed to be shown to the user who is using the browser, but rather to be processed by a markup language parser in order to properly display the content of the page or document. And most markup languages, such as HTML, XML, and so on, use tags with angle brackets as meta information to signal the beginning and the end of the actual content to be shown. Unsurprisingly, the tags cause additional overhead. This means that an amount of data has to be downloaded every time you open a web page. True, the amount is relatively small, but is also the reason why the JSON format is preferred over XML when dealing with transferring other types of data. Also, the parsing process is easier to carry out. As for web pages, I don't see any forthcoming alternatives replacing HTML anytime soon. So, let's go on and talk about, tags. We have body, P, A, they are opening tags, and there are also closing tags. The actual content is located in between the opening and the closing tags. Whereas HR and BR are self-closing and they don't need, therefore, any closing tag. HR means horizontal rule, horizontal line, and BR means line break. They don't need any closing tag. Yeah, let's talk about nesting of the elements. HR, BR, and P, they are all siblings because they're children of body, the main or root element. In turn, A is a child of P. This is called nesting. HR, P, and BR, they are all children of body. They are nested inside body. A is nested inside P. Now let's see the attributes. ID and class are global attributes. They are global because they can be applied to all elements, to all tags. Some attributes are non-global, as this one, OL reversed. Yeah, because OL means an ordered list. It's when we have first, second, third, fourth element, and so on. It is reversed, and other elements cannot be reversed because it would not make sense for a paragraph to be reversed. There's nothing to reverse at all. And mind that it is a Boolean attribute. You just write the name of the attribute without anything else following, whereas in normal attributes we have the name of the attribute equal and a string of text between a couple of quotation marks. Alright, let's take a look. Well. can see I'm writing in this field some lines of HTML language. h1 id equals title, very huge title, one unnecessary paragraph no one asked for. Also class equals paragraph written by a DNS. You can see I wrote a title and a couple of paragraphs. Now as for the CSS, title color red, par color light green. You might not immediately get what I am trying to accomplish. P2 color dark green. As you can see, something has changed, namely the color of the text. This means that attributes are functional to accomplish something along with CSS. They must be used if you want the style of the element to be changed in some way. Okay, enough. Let's proceed. Let's move on. Now I'm about to talk about something which is often overlooked, sometimes even by the teacher themselves, the importance of semantics. Take a look at these B and I tags and at these strong and EM tags. What's the difference between bold and strong and between italic and EM? Well, B and I are style tags. They respectively make the text bold and italicize the text displayed, and nothing else. On the other hand, the strong and EM are semantic tags. They indicate how something should be emphasized or pronounced differently. They do the actions mentioned above. They make the text bold, they italicize it, okay? Plus, they make all devices render the text properly, also early versions of the ebook Amazon Kindle. And they are used along with assistive technology. Text-to-speech will read aloud the text differently, and this is particularly useful for those who are visually impaired or have other related disabilities. Semantic elements are beneficial to both the developer and the browser. The browser can detect them and aid the user. You can see the difference between a header, a navigation bar, an article, a footer, and aside, something which is separate from the main article section. This is useful for the developer because after a year or so you can come back to your code and have totally forgotten what was the intended purpose of your element, your section, or if you happen to need to pass it on to a colleague, this is going to help you and them a lot. Also, assistive technology will read the content and convey information about it. You can identify headers and read them in a different tone. Everything, if possible, should be used at its fullest. This stuff is very, very helpful. Here are some HTML tips and practices for you. Number 1. Case sensitive doesn't matter except when it does. This means that when it's about the name of an element in between the angle brackets, it doesn't really matter if it's written in small letters or in all caps. However, that's not the same for the name of attributes. Attributes are case sensitive, as you can see. Number 2. White space among different lines is ignored, but not elsewhere. You can put as many carriage returns, as many line breaks as you want between the elements inside your HTML document. Got me? Number 3. Quotation marks are not part of a string except when they are. This means that you are given two different possibilities. You can write the name of your attribute between double quote marks or between single quote marks according to your needs. If your text, if the string of your attribute has a single quotation mark, then you would want to put it in between double quote marks and vice versa. You should use these tips to make your code readable and organized. They are absolutely a must, in my humble opinion. I'll proceed to inquire into the structure of CSS, the cascading style sheets. Using CSS, we can determine the visual appearance of our HTML elements independent of the HTML itself. You can remove the CSS part and replace it whenever you want to. And you have two options available. The first one is to use the style element to insert CSS lines of code inside your HTML document, and the second one is to provide a link to an external CSS file. The first option, using the style element. CSS rules are merely placed into the document. You write the style opening tag, you put some row CSS rules. When you're done, you write the closing tag and proceed writing something else. A second option is to use a reference to an external CSS file. You write link rel equals style sheet between double quotation marks, this is a constant, and you write href equals, and now your path. Take a look, css slash mystyles.css. What does this mean? It means that this document, of which we do not know the name, is located inside a folder that has a subfolder inside it called CSS, and inside this subfolder there is the mystyles.css file. This means that the root of the reference is the folder our original document is located into. Okay, let's now take a look at the components that make up a single CSS line of code, the basic CSS syntax. First and foremost, we have the selector. A selector is essentially a rule, a constraint, and every single element in your HTML page that satisfies this condition will be affected by the rules contained within the declaration curly braces. As for the structure of a single rule, we have the name of the attribute followed by a colon followed by the value, and in the end we have a semicolon. You can put inside the declaration as many rules as you want, as long as they are separated by a semicolon. Here are a few categories of selectors. First of all, we have the element selector. Every element whose opening and closing tags contain the selector will be affected by the rules. This technique can also be employed to create new elements, even though it's not really good practice. Then we have the ID selector. The single element whose value of its ID attribute matches the string of text that follows the hash will be affected by the rules. The attributes are all optional, but remember that every element having an explicit ID value is supposed to have its own unique value. There can't be two distinct elements having the same ID. That is why the class attribute exists, to arbitrarily group elements. And the class selector works in a similar fashion to the ID selector. Every single element whose value of the class attribute matches the string following the dot will be affected by the rules. Then there is the logical conjunction selector. Only the elements that match all of the specified criteria will be affected by the rules. The criteria can be multiple classes or an element and several classes, as long as there is no white space between them. You see, there is no white space between dot class 1 and dot class 2. Of course, there exists also a logical disjunction selector. The rules affect an element if it matches at least one of the specified conditions. In this case, the criteria must be separated by a comma. Various kinds of criteria can be thrown together in the selector. You see, element, paragraph, ID that must be equal to headline, class attribute that must be equal to interview, okay, and so on. Then we have the specialized selector. There are at least 50 other kinds of selectors, but these are the ones you'll need the most. The specialized selector works this way. If an element satisfies the last condition and one of its ancestors satisfies the previous condition, then it will be affected by the rules. This reasoning can be extended in a hierarchical way to increase the level of specialization. You can put more than two criteria for the element, its parent and its grandparent as well. Okay, let's see an example. H1 ID equals title, a new beginning, P ID equals Samsung 1, class equals phone positive. Mind that phone and positive are two distinct classes. The class attribute can include more than one value. They are separated by a white space. Phone and positive are two different classes. Samsung phones have a decent camera. Samsung 2 phone negative. This is a negative remark. On the other hand, Samsung phones cost way too much. Line break. Oh god. PAD equals Philips 1, class equals Blender positive. Philips blenders are very cheap. Philips 2, Blender negative. On the other hand, Philips blenders can murder you while you're sleeping. Okay, we have a title, a couple of paragraphs, then line break, then another couple of paragraphs, and we have some bold and italic text. Now let's apply some CSS rules. P color red. The text of every paragraph now is in a red hue. Next one, hash Samsung 1 font size 20 pixels. You see, the paragraph with Samsung 1 ID has been resized. Now the text is 20 pixels larger. That positive color green. Every paragraph belonging to the positive class now has a green font color. That phone, that positive color orange. The only paragraph belonging to both the phone and the positive classes now has an orange text color. That phone space B text shadow 2 pixels gray. The text in bold has been affected. Why? Because B as an element is a child of a paragraph that belongs to the phone class. You see, the element condition, the last one has been respected, and the previous condition referred to its ancestor as being respected as well. This is why it works. That blender everything. The asterisk means everything. The following rules apply to every kind of element. Text shadow 2 pixels blue. You see, the children of elements, paragraphs belonging to the blender class have been affected. It basically does the same as the previous line, actually. Hash Phillips 1, Phillips 2, color white. You see, multiple elements have been affected, namely the paragraph having a Phillips 1 ID value and the one having a Phillips 2 value. Okay, it was pretty easy in my humble opinion. Okay, now let's leave. We're not done yet, because we still have to inquire into something. You may have thought that the CSS rule that came later would override the ones that came first, but this is not necessarily true in all cases. In fact, it is true in only one case, if the selector is identical to the previous one. This priority chart tries to address this problem. What if multiple rules are trying to modify the same element by setting different values of one property? In the end, one rule shall always prevail over the other ones. First, we have a basic element selector. The rules will affect every element of a certain type, but if an element of that type belongs to a particular class, the rules with the class selector will take precedence. And if the element belongs to multiple classes, then the rules that involve the highest number of classes will prevail. Also, the priority of a rule with a more specialized selector affecting an element will be higher than the priority of more generic rules. But the rule having the highest priority of all implies an ID specified in the selector. This will override any other rules affecting the element. However, there are still a few ways to override even the ID rule. You can write another ID rule just below it. It's pretty simple, and unsurprisingly, this applies to every other kind of selector. We haven't run out of options yet. As a last resort, you can write !important after the value of a rule, and it will be the one with the highest priority, regardless of its relative position in the CSS sheet. Even if there are more specific rules coming later than this one, they will be totally ineffective. Let's see another example. Now, I'll try out something different, and this is also going to be a spoiler of what's coming next. Div ID equals 1, class equals main box. Two, 3, however, they are sub-boxes. Right, I'm closing it. Okay. Of course you can see nothing at all here because they are empty boxes. Div background color green, padding 20 pixels, border 2 pixels, solid black. Well, it's something. Now let's affect the sub-box classes. Background, no, width 300 pixels, height 200 pixels, margin auto, background color red. Yeah. Now guess which element will be affected by this third rule? Yeah, right, the third one, a sub-box that is contained within a sub-box. Width 200 pixels, no, 20 pixels, height 60 pixels, background color white, also margin auto. Yep. Now hash 3 background color purple. Now it has become purple. And now 3 background color, you know what I'm about to do, yellow important, no wait, yellow. Now it makes sense. If I write here important, it's purple. This rule has no effect at all. Now, do you want to have a proof that it's all about priority and the order does not really matter? Let me just shuffle the order of the rules. You see, I reversed the order and nothing has changed. This means that the order is irrelevant, it's all about priority. Okay, right. Right. It's about time we stop concerning ourselves with the rules that affect the rules. From now on, we'll focus more on the actual effect of those rules on the web page. To be fair, there are some things that you are supposed to know all along, from the very beginning of this course. This is why I didn't really cover the foundations, the practical side, the creation of tables, images and so on, because you likely have done all these things about 3 years ago. I don't know, you may have studied HTML even in your free time and already know this stuff, but then it's not my fault. In the past you may have followed instructions, tried out snippets of code from Stack Overflow, but now it's time for the theoretical part of your work. From now on you'll be able to act on your own and stop seeking help, and this is the layout design part.